Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through Pythagoras Theorem. So Pythagoras Theorem is used to find unknown sides in right-angled triangles. So here we have a right-angled triangle. We call the shorter two sides A and B, and C is the longer side, the hypotenuse. The longer side of any triangle is always opposite the largest angle. So in a right-angled triangle, because the right angle has to be the largest angle, C, the hypotenuse, is always opposite or not touching the right angle. So Pythagoras theorem says a squared plus b squared equals c squared. In other words, shorter side squared plus shorter side squared equals longer side squared. So we can rearrange this formula to help us find an unknown side. So rearranging to make C the subject, we have C equals square root of a squared plus b squared. You use this formula here if you're trying to find the longest side or the hypotenuse, and you use this formula here if you're trying to find a shorter side. All right, let's look at some examples. So here we have a right-angled triangle. We're trying to find the hypotenuse, which is the longest side. So we'll use this formula here. So here, x, doesn't matter whether you call it x, c, whatever, it will just be the square root of shorter side squared plus shorter side squared. Put that in your calculator. If you need to, you get 5. So over here, we're finding a shorter side. Here, 20 is the hypotenuse, the longest side. So x, one of the shorter sides, will simply be the square root of hypotenuse squared minus shorter side squared, and you can put that in your calculator to 2 decimal places. You get 17.32. So sometimes we get a whole number, sometimes we don't. The only real difference in these formula is that we plus when we're finding a longer side and we minus when we're finding a shorter side. So let's look at this example here. So we can go through these two formulas straight to those formula when there's one unknown side, but here we have two unknown sides. So we're going to need to use this formula, a squared plus b squared equals c squared. We can't skip straight to one of these formula. So this is an isosceles triangle. It has two equal sides. So both equal sides we'll call A. We have a squared plus b squared equals c squared. In other words, shorter side squared plus shorter side squared equals longer side squared. That formula holds for any right-angled triangle. So let's solve this equation. A squared plus a squared is 2a squared, and 8 squared is 64. So to solve this, we want to undo everything that's been done to a. Because of order of operations, we square first, then multiply. So when we are solving, we do things in the opposite order. Our next step is going to be to divide each side by 2 and then square root both sides. So a is the square root of 32. So square root of 32 is the exact length of the side. And we can also write that, if we put in our calculator, we get like 5.66. So this is just an approximate answer. It's a rounded answer. This is the exact answer. All right, let's look at a harder example now. It turns out we can also use Pythagoras theorem in 3D. So here we have a poorly drawn rectangular prism. We're going to find the length from one corner to the opposite corner. This value x, it can be seen as the length of the longest stick that could fit inside a box, a rectangular prism box with side lengths 4, 4, and 4. So this is actually a 3D problem, but we can reduce it to 2D problems. So let's find what x is. Unfortunately, we don't yet have a right-angled triangle. We can only use Pythagoras in right-angled triangles. So first, let's create one. Note here that this will be a right-angled triangle because the height of a rectangular prism is perpendicular or 90 degrees to the base. So this green line here is the diagonal of the base. Here we have to actually use Pythagoras theorem twice, once to find this length and then again in this 3D triangle. So how do we find it here? Well, we have at the bottom here a square that's 4 by 4. So because it's a rectangular prism, we know this will be a right angle. So this side here, I'll just call it C. C is just going to be the square root of shorter side squared plus shorter side squared. It is the hypotenuse, that's why we plus in the formula. So the exact value for C is, again, root 32. I don't want to round this value here yet because I'm going to use it in my next calculation. So now we have a right angled triangle where I know 2 sides. So to find x, it will just be the square root of shorter side squared plus shorter side squared. So square root of 32 squared is just 32. X will be the square root of 32 plus 5 squared is 25. So the exact length here will be the square root of 57. And the approximate length here is about 7.55. And that is the distance from the bottom left corner to the top right corner of this rectangular prism. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.